It's welcome back to my YouTube channel, The Nautical Guru, and Facebook page, Merchant Navy Knowledge. Those who have not subscribed to my YouTube channel, kindly subscribe, and those who have not followed my Facebook page, kindly follow my Facebook page. So guys, today video is about the marine sextant. Our learning objectives will be overviewing the parts of the sextant, know how to take a sextant reading, and to know the corrections applied to sextant altitude and to obtain observed altitude. So in the diagram you can see the parts of the marine sextant. We have a frame, an index arm, an arc, a release lever, a micrometer drum, a handle to hold the sextant, index mirror, index shade glasses, horizon shade glasses and a horizon glass, and a telescope. So historically the sextant is constructed to allow angles up to 120 degrees, that is 1/6 of a circle. That's why the name sextant to be measured. However, the arc of the most modern sextants can be extended so angles up to 145 degrees can be measured. So this is a diagram of an index arm which is moved on the arc for taking the reading of the sextant, and after taking the reading there are certain errors which are applied to the reading. So further going to detail, we will tell you that there are some instrument errors which are adjustable and some are non-adjustable. So first of all I will talk about the adjustable errors. First of all is the lack of perpendicularity of the frame and the index mirror. Then there is a lack of perpendicularity of frame and horizon glass, that is called a side error. Non-parallelism of index mirror and horizon glass with each other at 0 settings, and non-parallelism of the telescope with the frame, which is also referred as collimation error. Then there are some non-adjustable errors. This include prismatic error, which occurs because of non-parallelism in the faces of the shade glasses, index mirror and horizon glass. Second is graduation error resulting from improper calibration of the scales of the arc, micrometer drum or vernier. Third one is centering error, which occur as a result of the index arm not being pivoted at the exact center of the arc. So there are certain corrections which are applied to the sextant altitude so that observed altitude can be obtained. So we will talk now about what are these corrections. All these corrections are applied to each sextant observation. However, every sextant altitude must be adjusted by one or some of them. All but one of the corrections are found in Nautical Almanac. First one is index error. It occurs because of non-parallelism between the horizon glass and the index mirror. To elaborate further, kindly go through the figures. In the first figures you can see the sextant is set at 0 but the horizon is not in line, so there is index error present. And in the second diagram you can see that the sextant is set at 0 and there is no index error. Then comes the dip corrections. It accounts for the difference between the line of the sight of the observer's sea horizon and a horizontal reference plane parallel to their celestial horizon, as explained in the figure given below. This correction is called as the dip correction or simply dip, and the value of this dip is always negative, and you can obtain these values in the Nautical Almanacs, which is different at different height of eye. Once the index error and dip are applied to the sextant altitude observation, a new value which is called as apparent altitude is obtained. The apparent altitude is entering augment in the nautical almanac to obtain the rest of the sextant altitude corrections. Other errors that will include after implying this index error dip will be the refraction. Refraction is basically, as explained in the figure, bending of light as it enters the earth atmosphere. As in the figure you can see, the actual position and the apparent position of the star is different. Then comes the semi-diameter. It is usually applied to the sun and the moon. The apparent altitude must be increased by the amount of half the diameter of the body when the lower limb is observed. Then comes the augmentation. The increase in the apparent size of the moon as a result of observer's distance result in increase in the apparent altitude. It is explained clearly in the figure given below. Then comes the phase. It compensates for the fact that the actual centers of the moon and the inferior planet Venus may differ from the apparent center because of the phase of the body. Then comes the parallax. It is applied to Sun, Moon, Venus and Mars. Adjustment for the radius of the Earth caused by the parallax, the difference in apparent altitude of the body as viewed from the surface of the Earth and from the center of the Earth, the same thing is explained in the figure below. So guys, in all we can say that to all the sextant observation we will apply index error and dip, and if we were talking about Venus and Mars, we will apply refraction and parallax after applying index error and dip, and in Venus we will also apply the phase. When we are taking measurement from Jupiter, Saturn and other stars, other than index error and dip we will apply refractions, and when we talk about the Sun we will apply refraction, parallax, semi-diameter other than index error and dip, and when talking about the Moon, additional to index error and dip we will apply refraction, parallax, diameter and augmentation. So guys, if you will like my video, kindly subscribe to my channel The Nautical Guru and follow my Facebook page Merchant Navy Knowledge.